Hey friends, welcome back. So far in the module, we have explored our dataset, trained it and trained two models, logistic regression and decision tree. But here's the question. How do we know if our models are actually good? This is That's what we will talk about today. Evaluating classification models using two important tools, accuracy and confusion metrics. Let's first understand accuracy. Accuracy is the simplest and most common way to evaluate classification model. Accuracy tells us what percentage of predictions the model got correct. The formula is simple. Accuracy is equals to number of correct prediction divided by total prediction. Example, suppose we have 100 passengers. If the model predict 85 correctly and get 15 wrong, the accuracy is divided the accuracy is 85 divided by 100, which is equals to 85%. So the accuracy gives us a quick sense of how often the model is right. But accuracy has a limitations. If the dataset is unbalanced, like if 90% of passengers did not survive and only 10% did, a model that predict not survived for everyone will still have 90% accuracy, even though it's actually useless. That's why we need more than just accuracy. That's where the confusion metrics come in. So what is confusion matrix? A confusion matrix is a table that shows us where the model is making mistakes. For binary classification, it is a simple 2 by 2 grid. On one side, we have the actual values, what really happened. On the other side, we have the predicted values, what the model guessed. The confusion matrix has four parts, true, positive, or you can say TP. These are cases where the model predicted yes survived and the person actually survived. True, negative, or TN. The model predict no did not survive and the person really did not survive. Third, we have false positive, or you can say FP. The model predicted yes survived, but in reality the person did not. In other words, it raised a false alarm. Fourth, we have false negative. The model predicted no did not survive, but actually the person did survive. Here's the model missed the real positive case. So the table looks like this. Top left, true negatives. Top right, false positive. Bottom left, false negative. Bottom right, true positive. Why is this useful? Because now we don't just know how many predictions were correct, we know what kind of mistake the model is making. For example, if there are too many false negative positives, the model is too optimistic, predicting survivals when it shouldn't. If there are too many false negative, the model is missing real survivors. Different applications care about different mistakes. In spam detection, a false positive means a good email got marked as spam. In medical test, a false negative means a sick patient was told they are healthy, which is much more dangerous. So confusion metrics give us deeper insight beyond accuracy. So what's the difference between accuracy and confusion metrics? To summarize, accuracy is one number that tells us how often the model is right overall. Confusion matrix is a table that shows exactly where the model was right and wrong. Both are important, but the confusion matrix is especially powerful when we care about the type of error, not just the total number of errors. Great job. Now you know how to evaluate classification models using accuracy and confusion matrix. Here what we learned today, accuracy, total correct predictions divided by total prediction, confusion matrix, a breakdown of true positive, true negative, false positive and false negative. Accuracy is quick and simple, but confusion metric give us a much deeper picture. This wrap up our classification basic module. In the next step, we will apply classification to a larger dataset and see how these models perform in the real world. See you there, friends.